We are going to introduce the laws of sines today. So for a review here, example 1, use a calculator to find each trigonometric ratio, round to the nearest hundredth. So if you type the sine of 135 in your calculator and round to the nearest hundredth, you are going to get about 0.71. If you type the cosine of 92 for part B in your calculator, you are going to get about negative 0.03. And then for part C, the tangent of 175 degrees, if you type that in, you will round and get about negative 0.09. Then we're going to move in here to the laws of sines. So you probably should write this down and try to color code it or shade it or make it distinctive to what we have going on here with the red, green, and blue colors. So the laws of sines says that any triangle named ABC here with side lengths of lowercase a, b, and c, if we take the sine of angle A and divide it by the length of side A, which is opposite. So this is what I want you to notice. Sine A divided by the side length of A, it's across, it's opposite from the angle, okay? Is the same thing when we take the sine of B and divide it by side length of B. So angle B is right here. Opposite side would be the length B. And when we divide those, we'll get the same thing. And then we also get the same thing when we take the sine of angle C, which is right here, and divide it by the side length of side C. Okay. So pay close attention that whatever angle we're talking about, the side length is opposite of it. So we can use the laws of sines to solve a triangle if you are given two angle measures and any side length. So angle, side, angle, or angle, angle, side. Or if we're given two side lengths and a non-included angle measure, and that would be considered side, side, angle. Notice that this triangle is not a right triangle. We were using right triangles up until this point. So the SOHCAHTOA goes with the right triangles. The law of sines goes for the other triangles. So, for example 2 here, it says to find each measure and round your lengths to the nearest tenth and angle measure to the nearest degree. So for part A, they want us to find the length of side DF. So they want us to find this right here. So we know the measure of angle E, and the opposite of that would be our x. So we know that the sine of 32 over the side length of the opposite, which here is x, is going to be equal to, we know this angle of 105, so angle D, the sine of 105 over its opposite side length, which would be 18. Now we just set up this proportion here, and we are going to cross multiply to solve our ratio. So the sine of 32 times 18, and I'm going to put that 18 out front so it doesn't get messed up with that 32, is equal to x times the sine of 105. So this is now an upside down t problem, and we want to solve for x. So x is being multiplied by the sine of 105, so we're going to divide by the sine of 105 on both sides. So they cancel here, and we would have x equals, and we can type that in, 18 times the sine of 32 divided by the sine of 105, and we're going to get about 9.9. So the side length of side DF is about 9.9 units. And for our last example of the day, we are being asked to find the measure of angle S here. So we have to find that measure there. Now we know angle T here is 75 degrees and its opposite side is 7. So we can say that the sine of 75 over 7 is going to equal the sine of x, since we don't know that angle measure, divided by 5. And we're going to cross multiply here. So I have 7 times the sine of x is equal to 5 times the sine of 75. Then we're going to have to do an upside down t problem. And we have to get rid of the 7 out here. It's being multiplied, so we're going to divide both sides by 7. So we get the sine of x left here on this side equals 5 times the sine of 75 divided by 7. And then in order to solve for that x here, we are going to have to take the inverse sine of both sides. And when we do that, we are left with x on this side. And if we type the inverse sine of 5 times the sine of 75 divided by 7 in our calculator, we get about 44 degrees.